Last year, when we did quadratics, we talked about a lot of this stuff. So let's go through it again together. A function, we're doing functions and function notation. A function is a rule. It is where we have a variable y is a function of a variable x, when y is completely determined by x as a result of some rule. There we go. Yeah, that one there. Okay. Informally, we say that y is a function of x because the value of y is determined by the value of x. And we call x and y the variables because they can take on many different values that we can sub into them. Now, we have special names for them. The variable x is usually called the independent variable of the function. And the variable y, and I'm saying usually because I could change it, is usually called the dependent variable. Now, what that means is if I give you a made-up function here, okay, there's a made-up parabola, okay, the x value is independent because I can choose whatever x value I want. Doesn't matter what the y is doing, I'm choosing the x values to put into it. But the y values depend on the x values that we put in, which is why they are the dependent variable. So x is independent, we can choose what we want to put in, but y depends on the value that we sub into it. Okay, so that's independent and dependent variable. So then we get to the function notation part. When using function notation, we use y is equal to f of x. So instead of saying y is equal to x squared plus 2x plus 5, I replace that y with f of x equals. And that's because we're saying that y is a function of x, because x is the independent variable and y, the function, depends on what x is to get the y value. Okay, so that's why we call it that. If we have y equal to f of x, if we have f of a, that means for every value of x, we would be subbing a, whatever value a is, we'd be subbing that into our function. Okay, which is what we're going to be practicing right now. So example number 1. I'm giving you a function, f of x equals x squared plus 2, and we want to find f of 3. So you can see the 3 is in the spot where we normally have the f of x part. That means we're replacing the x with the 3. So in that function, the x squared plus 2, that is going to become 3 squared plus 2, just replacing the x with the number 3 that I've been given. In your calculator, you work that out, and so that f of 3 is equal to 11. Okay, we do it again.
Wait, do we need a calculator for that?
Oh, okay, you don't need a calculator for that. You don't need a calculator for that. Of course not. But you work that out. Okay. F of minus 2 just means we're now putting minus 2 into our function everywhere where there's an x. So that means minus 2 squared plus 2, which of course I've put into brackets so that you remember to square the negative. So 4 plus 2 makes 6. Part C, f of minus 2 plus 2f of 3. Now we've worked out what each of those things are already. We know what f of minus 2 is. It was equal to 6. We worked that out in part B. You could work it out again if you wanted to, but we worked that one out already. So we'll just sub that straight in. That was over here in part B. F of minus 2 was 6, so I can just put that in for that one. Then I want 2 lots of f of 3, and then we worked that one out already, which was 11. So 2 times 11. Now it's not just numbers that you can substitute in. In part D, we want to find f of 2a. So everywhere where there's an x, we put 2a, so it's going to be 2a squared plus 2. That means that I have to square the 2 to become 4a squared plus 2. And I can't do any more than that unless I'm told what a is, because that's from here, it was x squared plus 2. Yeah, from here we're subbing to there. Ashton, Monty. It's a funny noise. Can anyone else hear that? No, just like, don't worry. Oh, that's what it is, outside. Okay, question 2. Find the value of x for which f of x equals 0, given that f of x now equals x squared plus 4x minus 12. Now, careful with how that is written. F of x equals 0. It's not the x that equals 0, it's the whole function that equals 0. In other words, where the y part normally is. This bit at the beginning, I'm going to highlight it in green now. That is the f of x. That is the part that's equal to 0. So it is 0 equals x squared plus 4x minus 12. And here it is already, a quadratic that's creeped into our next topic. We now need to solve that to find the x values. So we're looking for numbers that times to give minus 12 and add to give a 4.
Minus 6. Oh, that was quick.
How about a plus 6 and a minus 2?
Oh, sorry, my bad.
Had the minuses around the wrong way. So using null factor from there, from the first bracket we would get x equals minus 6. And the second bracket, we would get x equals a positive 2. Next page. Hopefully that's all familiar. Next page. Question 3. Find f of 2, f of 1, f of 0, f of minus 3 if f of x is defined by this lovely looking thing here. Okay? Now, it's not as bad as it looks. It's not as bad as it looks. What this means is, depending on what value of x I give you, if I give you a value of x that is greater than or equal to 2, then we use this top function. If I give you a value that is less than 2, then we sub into the bottom one. That's all it means. Okay? So, f of 2, oh, that's right on the line, isn't it? So it's going to be the one with the equals 2. Okay, not that one now, it has to be less than, can't be equal to. So equals 2 has to be this top function. I'm going to be subbing into the 2x plus 3.
Who was that?
All right. So the x becomes a 2. Shh, calm down. 2 times 2 is 4, plus 3 is 7. Next one. No, f of 1. Can we stop the chatter, please? F of 1. 1 is less than 2, so we're going to be subbing it into this one. So it's going to be minus 4 times by 1. I'm going to sub it straight in this time. Minus 4x or minus 4 times by 1. Which is minus 4. F of 0 was the next one. So 0 is also less than 2. So into here, minus 4 times 0, which is 0. And there's one more, F of minus 3. Still less than 2, so we're still in this one. So minus 4 times minus 3. Gives a plus 12. Very good. Last question. Question 4. Let f of x equal, so it's just like the last one. If x is less than 1, whoop, that was meant to be the highlighter. If x is less than 1, we're using the top line. If it's greater than or equal to 1, we're using the second function. Now it says we want to create a table from x is negative 1 to positive 3. So that's our good old table of values, like this, x and y like that. We start at negative 1, and we're just going to count up. So 0, 1, 2, and 3. And we stop at the 3 because it said between minus 1 and 3. Okay, so now we're going to sub in, as long as we make sure we sub into the correct function. So the first value I have is -1. -1 fits into this category here. It's less than 1. So we're subbing into there. Okay, now you can put this straight into your calculator. So you put a bracket here, you go 2 times -1 -1, close bracket squared, or you could do it in your head if you like. Anyone get an answer?
4.
No.
9.
9.
Did you do that in your head?
9. 8.
Guys,
You didn't put the thing.
do I need to show you that on the calculator? Are you right to do that?
No, I just
subject.
Okay, thank you. So do the next one, 0. All of you do it. This is your practice time. So 0. 0 is going to fit into this one again. It's less than 1. So we're putting 0 here. 2 times 0 minus 1 in bracket squared is 1. Good.
1.
Now we're equal to 1, which means we're jumping down to this formula. So 3 times 1 squared is 3. Good. 2, still in here. 3 times 2 squared is 12.
You had it on.
And last one.
27.
Oh, too easy. Too easy.
Wait, did you work that out?
Using the calculators.
I almost did it. Mate, did you think I used